All right, I have a few things to talk about, but if you want to start off with questions, I'd love to take them. Yeah.
I guess I was kind of confused on how we're functioning the pipes, because when I was working on it over the weekend, I was using the pipe and fork CPP file as kind of a baseline, building off of it.
All right, so let me grab that. That isn't it. What was was the 28th the last time we met?
Yes.
Where's that pipe and fork program?
Probably the 26.
There we go. All right.
So I'm not sure I understand. I'm just a little confused. And it seems like this builds a one-directional pipe, right?
Well, yes and no. It actually builds a two-directional pipe. Unfortunately, this example only requires information to go one direction.
Okay.
So there are basically three prongs that you need. You need the FIFO, the named pipe, and then you need the two directions. And this does the FIFO, and it does the one direction. It actually opens up communication the other direction. It's just never used in this example.
Okay.
So that is the right to, let me see, it's read from child that's used. Is that correct? Yeah. So here's the read from child, but the right to child isn't used, but it is open and ready to go. So if we can, I guess we'd try quickly tweaking that. Let's.
You said the parent open up the file and send.
You mean to use the other one?
Yeah.
Well, let me. Yeah, let me see. I need to think of an example where. All right, so I think, how about paste? I'm trying to figure out an example that would use both the named pipe and require both directions, input and output. Paste might do the trick. Let me see, if I say paste pipe and fork, no, probably fool it this way. I need something smaller. Smaller. The quick brown fox. How about that? And then what if I do this direction? Printf jumped over the lazy dog, and redirect that to shoot, where would that go? Yeah, this isn't gonna work. Let me quit this. All right, so let me just make FIFO pipey. Change this to pipey. Huh?
What are we trying to do here? It's not some of the steps are not very clear.
I'm sorry. I'm brainstorming in my head, and I'm just trying to come up with an. I want to tweak pipe and pipe.
Could you just open up the file from the parent and then write that to a pipe and just have the child run word count, but act like it's reading standard in?
I can, but then I shift from using the FIFO. WC is using the FIFO and standard out. I can change that up so it's using standard in and standard out, but then it's not using the FIFO. So I'm trying to find something that uses all three. And I think I got it. So let me run with this and see how far I get before I hit a brick wall. So what I can do is, I assume, which paste. What all paste does is it takes two files and it concatenates the first line of both files, the second line of both files, the third line of both files, right? Just that. So this is one file right here, and this is a second file here. So it puts a tab between them, and otherwise you get the first line, second line kind of married up that way. All right, it's in user bin. And it's where you want it to grab one file from the pipe. Oh man, this is going to work.
It needs two files.
Well, I can force the other file to be standard in.
Standard in. You specify standard in as an argument.
It isn't going to work the way I have it written. It's going to end up. I'm going to end up blocking. So let's do it. Let's go ahead and just ignore. We know this works with the FIFO, so let's ignore the FIFO then.
Can we write standard in into a file or a FIFO and then specify that as the second argument for
Yeah, it isn't going to work with paste because I have to feed one line from each. In the way I have this written, I'm feeding an entire file to the named pipe rather than one line at a time. So rather than re-architecting this thing to do that, I'm just run with my tail between my legs and ignore the pipe. Since we know that part works, we just set it aside. All right, so here I am. I'm opening it up with no argument, so it is not going to do counts of a file. It's going to do counts of whatever I type in.
standard in.
Yes, standard in. All right, so I get all this set up just as before. Here's the pipe stuff. So what I'm going to do is I'm just going to comment all that out. Maybe I'll ultimately delete it since it's in that other file, but until I got this working, I'll leave it commented out in case I've done something horrendous in commenting that out. So this is reading the results. So before I get the results, I have to write information to it. So what I will do is I will create a constant character pointer text, texty, and that will be the quick brown fox jumped over. And so that should be 6 words, 3 lines, and I don't know, 20, 25 characters.
But foxes are red.
That's not how I learned it. So now I need to just simply write to child. before I read. This is going to be right. It's going to be texty, string length, texty. Let me pause and think about this for just a second. Let me go ahead. This is buggy, but one of the things I wanted to talk about today was introducing some debugging strategies. So let me leave the bug in here and run it, and then let's debug it. So I say G++. Standard equals C++17 for that looks like I've got leftover code in there. So let's figure that out. So I shouldn't have this in here. So that's I forgot to comment out. I think that's all of my named pipe stuff, and then this is the two-way communication after that. Oh, I'm not even running. I need to be running in my virtual machine. There's another problem I got going. G++, standard equals C++17, pipe and fork. Let me get rid of pipey. And that's left over from our named pipe. This should hang. It hangs. Okay? As I said last time, this is what a lot of this project's like. This is exactly what you see here. And it's not encouraging.
For input.
Huh?
Waiting for input.
No, I provided the input. Well, let me just say we don't know why, right? So what we want to do then is we want to look at this tool here, trace system calls and signals, strace. And it has one option that we are keenly interested in, and that is an F, I believe. Let's see, let me search for -F. Not the -FF, just the -F. Trace child processes as they are created by currently traced processes as a result of a fork. So this is just what will happen is in the absence of the -F option, it is just going to trace the parent and it will ignore the child when it forks off. We're definitely dealing with communication between the two, so we want to see the trace of both of them kind of combined in the same file. Now, it's simple to use. All you have to do is say strace, give the name of the executable. Now this is going to produce output to standard error. So you want to redirect standard error to an output file. I don't know, it doesn't matter what you call it. If your strace is, I don't know how standard that suffix is, but I know that Vim picks up on the strace suffix on the file and will give you nice syntax coloring for it. Your mileage may vary if you're using a different editor, but try doing strace, and if you're not getting syntax coloring you like on your editor, then that's where Google's going to come in. So this will end up freezing again, but I believe it should have produced something to our strace file. So let me just do Control-C to break out of that. Do an ls, let me do an ls-l, and we did get some information. I'm flying without a net here, I didn't do this ahead of time, so let's see what we end up with. Yes?
How we run that? Does it take the system calls that the parent execute or that the child executed, or both?
Every system, but that's what the dash, oh, did I do the dash F option?
No, just the regular one.
Dash F, I forgot that. All right, let me add that. Now I'll break out. Now I'll bring it up. All right, let's see, where's this ending?
And how do we know which does it belong to the child or the parent? Each system call.
See, we're getting these questions answered. So a lot of this first, there are going to be many lines here that you totally ignore. And the reason you totally ignore them is they're things like when it's first starting up and it's linking in shared libraries and stuff like that. All that stuff just set up before you hit the first line of main, right? And it doesn't really concern us. There's a really nice, how traditionally, how we kind of do CR, I am here 1, I am here 2, right, that style of debugging. There's some neat tricks you can do to integrate that into strace, and let me go ahead and actually do that. Let me go to the first line of main and say write to 9876. Doesn't matter what I write. This is going to fail. Well, and I have to provide whatever. I don't have to do all this, but I will. Actually, let me make it 4 nines. So this will fail spectacularly because there is no open file descriptor, 9999. Well, that doesn't matter. The system call is made, and then the system call itself discovers that it's unsuccessful, right? So I don't care about whether this call is successful or not. What I care about is it's going to put an entry in that strace log. So that's where my program begins, right there. So let me compile it again and run it again. Whoops. Run it with the strace. There we go. Break out. Bring up my strace log here, and if I look for 9999, we see 73 lines down. That's where my program begins.
-1 bad file descriptor.
Yes, and you can see a pattern in how these work. It shows the system call that was made and what that system call returned. And so here, we even get a version of Pierre here. So it's actually quite nice what this strace produces as output. Here are the pipes we create. Remember, these create the one's input as the other's output. So 3 is input. Whatever goes into 4, whatever you write to 4 can be read from 3. Whatever you write to 6 can be read from 5.
And there, notice that those file descriptors there being incremented up by 1.
Right. You start with 0, 1, 2. So it's as we would expect, is picking the next available numbers. So we're seeing all that realized.
Isn't an error if you write to 3? Try.
Wait, look, let's give it a try. So, and now I'm confident that I've got all this stuff stripped out successfully. So let me go ahead and start stripping all that named pipe stuff out of here. Is that right? Yeah. No, that isn't part of that. But I get rid of that anyway. All this, so this is 45 through, no, 46 through 56 delete. And that. All right. So we wanted to come to this, and what we'll do is we'll put a write here, write to child 0, or if I wanted to, we all know here that it's 3, right? Write to 3. Those are the same thing. When we look at that strace output, we don't see to child 0. What we see is 3. So it doesn't matter. I'll go ahead and stick with this. And I guess I can just count that 5.
Yeah, hard coding your string lengths. Very safe.
Let's try. So what's going to happen? Tell me what's going to happen if I.
Is it because it's opened up as read only?
Yeah. So you can't write to it. What if I? Tell me what's your prediction if I write to 1, which we are allowed to do, right? We would assume.
Go through successfully.
Shall we see? All right. Here's. Now we should see something very different when I open up this log.
Yeah.
Thing. So let's see. Yeah, we can't tell what we're seeing different until we see the original, so it doesn't matter. It isn't going to be useful to look at that at this point. So let me get rid of that.
Professor,
Yes, sir.
what if can we write to standard in and then use that as our input? Can we write something to standard in?
No, it's an error to write to standard in. So it's open for read only.
I don't know.
Now you can close file descriptor 0 and reopen it for whatever you want.
Reopen it and then you can.
You could reopen it. You could close file descriptor 0 and then open it up for write only if you wanted. So sit back. Actually, what we need to do is all right, let me compile this. Too many pluses. strace, a.out, to log.strace. Let me actually, for what we're talking about, let me change it up. Let me do oops. Pilot. Strace. Holder, am I 23? You're 23 years old. All right.
Right.
So if I take an existing executable, of which this is one, and before I fork off a child and say exec this executable, I can go ahead and do whatever I want with file descriptor 0. As I said, I could close it and open it up for write only, yes? Okay. So the question is, well, what effect does that have on existing executables? Well, this is your existing executable. That just means any read that you have on file descriptor 0 is going to fail. Does this make sense? So when you think in system terms and you think of existing executables, don't think of anything as being hallowed about standard in and standard out per se. Think of it as what you're doing is you're creating a compiled executable that has a whole bunch of writes hard-coded to file descriptor 1 and a whole bunch of reads hard-coded to file descriptor 0. So it's within your power to do whatever you want to with those file descriptors. If you want to, oh, watch this clever joke, and then you close 1 and open it for read only, and close 0 and open it for write only, go ahead and do that, but every single read and write to standard in and standard out of your existing executable is going to fail. Right? That's all you're accomplishing. So I think the key takeaway is to keep in mind that idea that when you're using cin or cout or printf or scanf in the C world or whatever, it all compiles down to system calls that are just writing to file descriptor 1 or reading from file descriptor 0. Okay? And so in a sense, those file descriptors are used by convention, right? Could have just as easily have could have been file descriptor 1000 and file descriptor 2000 for reading and writing. But by convention, they go ahead and make 0, 1, and 2, input, output, and error, because if everyone in the world agrees on that, then everything is predictable. All right. So let me go back and compile my pipe and fork. Let me run strace on that with the -f option. Let me close that. And let me go back to where we were talking about this. So again, what we're doing is we're running that WC program, which is reading from standard in and writing to standard out. And I went ahead and am writing to the child now. We've replaced the child standard in and standard out with reads and writes to this pipe. And we've written to the child, but I'm saying that there's a bug in it. And indeed we saw the bug because it did not execute and give us a count of characters, words, and lines, but it just froze there. So we want to get to the bottom of why that is. So we look at this log. And it's right around 73, right? There's I threw that in there just to show you where the beginning of main was. And again, you can put these anywhere in your program. Choose whatever numbers you want, choose whatever text you want, and they're nice markers to mark where you are. Note that one thing that you might consider doing is creating either a macro, a C-style macro, or even better, a C++ kind of template function where you feed in whatever string you want and it'll automatically kind of write out the information you like. Why that's useful is that you could include like variables and stuff like that. So you can say x equals and then it'll show what that is right here in this text right here. Right? So you can get valuable debugging information into this log that way. Anyway, we create the pipes, we do the dupes. It's a whole bunch of closing. Here's the write. And now we see process ID 1095 and we see 1094. Normally we see a lot of 1094. So which is the parent and which is the child in 1094 and 1095?
The parent is the lower one.
Right. So normally you have a whole bunch of 1094s in this case example, obviously. To go with 1095s, what I like to do is to search for PID. Whoops, where did that? So what do I have here? 1, 2, 3, 3 spaces, or 2 spaces. And I like to say CHILD, and then I 1, 2, 3, 4. So I'm taking the same amount of space. But now that says child everywhere, and then I do something similar, and instead of 1095 here, and I actually space it differently. I like to put this like that, so that when you're looking at a whole bunch of these end up getting, it's very nice to look at now, but it gets very intertwined, where you have stuff like, right, stuff that looks like this, and it's impossible to parse the 1094s and 1095s. It's very easy on the eyes to parse which is the parent, which is the child, and when it's formatted like this. So something else that you might want to do is find out what are those PIDs and write the substitutions to change child and parent. Do whatever you want. Just make it easy to distinguish between the two.
So it's like now it's in constant time, but it takes linear time to actually scan through the list and look at all the PIDs.
So this is the child now. We've got the fork and the exec happening. Here's the fork has happened, so inside that, I guess let's look at that code for a little bit. Vagrant. All right, here's the fork, and then we immediately, if you're the child process, you're going to do some dupes and a bunch of closes, then the exec. So here's the child, there's the dupes, a bunch of closes, and then the exec. All right? So it's at this point right here that this particular executable is no longer useful for us to track the child, because as soon as we hit the exec, we start seeing system calls of the WC program, or in your case of the gold chase program, is what the child will be at that point. So again, it's probably going to be about 70 lines or so, would be my guess. And here's a clue. System calls do get split a lot, so you do see, let me see if we have this word anywhere else. Yeah, this example is only revealing the bug, but just to say it, you will have a lot of system calls that'll say unfinished, and then it'll resume it somewhere else. And so sometimes you have to track two different locations for the beginning and end of the call. So it'll be the parent begins a write, and then it'll be a whole bunch of child stuff, and then it'll be the parent finishes the write kind of thing. But this is actually giving us a clue as to what the bug is in my program. So again, the write is occurring, and now this is the child doing a read, and it never finished. Why did it? Well, so this is in essence where I hit Control C.
So wait, so that line 163, that's in the parent, right? So does that resume from the previous line or from the line on top?
No, it resumed from up above.
Yeah. It resumes.
But in essence, we're essentially getting the hang right around 162. Why does the child? That's where our program in essence was sitting. So the child was doing a read and it never finished reading. Why is that?
Arguments, perhaps.
We actually went into the reason last time, but let me.
Because it was never closed.
Because it was reading from standard in.
All right, it's reading from standard in right now. Why? It's still reading. It's hanging on a read. Yeah?
Control D.
Huh?
Control D maybe.
Yeah, but what's Control D doing?
And the file.
Right, it's not end of file, it's closing the file descriptor.
It's right. This is write and end the file into the.
No. End of file is a response that the system call is giving you. The system call is trying to read, and it fails because someone closed that file, closed the write end of it. All right, so let's go in. So that's my error in this. Oops, I got it open elsewhere. So what I need to do is find my write. Here's my write, and then I need to close write to child. Let's see, is I doing it here? Error. Went all the way.
So in that case, it's a sense like when you're communicating from parent to child, it's pretty much a one-way street per communication, right? Because I mean, if you got to send something one way, then you got to close it for it to continue, and then you got to do it again, and then.
Not necessarily. It isn't necessarily closed to continue. Because the difference is that WC doesn't know how much information to expect, so it's going to keep sucking until it's closed down. In your case, your game process, remember when I said, okay, you call the map constructor, why don't you write out the rows and the columns and a copy of the map? You, on the auto test side, know exactly how many bytes to read in. So you'll read in 4 bytes for the rows, 4 bytes for the columns, and then you'll read in rows times column bytes, right? And so you get these hangs, but it isn't as a result of not closing things. It's a result of the game is trying to write out information, but your auto test thinks it's somewhere else, and it's trying to write out information, right? When it should be reading, so the game can continue. That kind of thing.
Gotcha.
So that's where the hangs come.
Okay.
Is when you get the reads and writes out of sync. So it's a synchronization dance is what it is. And look at that new. So I'll go ahead and let me see, this is 1111, that'll be my child, and 1110, that'll be
14.
Alright, so we jump down there. It looks like we've got 73-ish lines. So here's the write, there's the close. All the startup stuff for WC that we ignore.
Resume. It says read resume. That's from line 85. Looks like.
Mm-hmm. Let's see. Trying to find the exact place. So this is the child writing out the results here, right? And then that's the parent reading the results. Is that right? Those numbers aren't matching up though. Yeah. Okay, yeah. I was thinking of split into two reads, and I was looking at this, thinking that isn't enough, and then we have these two here, right? So that matches up with our understanding. If I look for if I go up to the top to 9999 again, here's the beginning of that read. And now it hangs because it has to wait for WC to do its thing. WC does its thing. Let me find, let me go 72 down. Oh, I was at 72 down. 72 down. I want to say that what I want to find is, there it is. That's what I was looking for. So I created a buffer of, it looked like 16K there, a big 16K character array to read in, and it only got 32 back, which is fine. It's going to keep reading. And when it keeps reading, then that's when that number actually is quite useful to search for. Here's where it does another read, and it doesn't get anything back. And so it closes up, and away it goes. So it's not the easiest thing to pull apart, but and part of the problem is we don't have control over WC, so we're not sure of exactly what's inside of it, other to see we've got the reads in there and then the writes. It'll be a little bit easier for you to tell apart your child, since your child is a gold chase, and you go, okay, now it should be writing out the rows, here's the rows. And to the extent you get lost, you just put one of those right 9999s in there, right? And you put it right above where gold chase is supposed to be writing out information, and then that'll help you quickly identify it in this log where it is, and then you need to, maybe you write out 8888 in the parent for where it's reading that information, and you try and find out, well, why are they not syncing up here? And then you can see them getting out of order or something, and then that allows you to debug it and move forward. Yes?
I want to talk about how we have the parent and the child is one, the process ID of the child is one greater than the process ID of the parent. Is it because when a new process starts, it gets assigned the next incrementing process ID as a kind of global?
Yeah, the kernel just keeps a serial number that it increments with each child, with each process it spawns off.
What if just before the process?
Then there'll be a skip. It just won't be contiguous, right? It's certainly possible other processes get started between the parent and the child, in which case the child gets whatever number's next, and it's not necessarily the next one. But likely, at least in my case, very likely, given that I'm running a virtual machine that's got almost nothing going on with it. But obviously it's easy to figure out which number is greater than the other. That's essentially all you need to do. It gets a little more involved when we deal with two children. Then you have three process IDs in here. So you'd probably put like child -A, child -B to help tell those apart. So let's talk about what tests you should actually do. So this is misleading in how it looks. So here's the original presentation of the files. This is not just something to read, but actually if you click on this link, that's how you submit this assignment. Okay. This whole description is describing how to create a patch file. If you recall, there's going to be a difference between your Project 1 submission and your Project 2 submission. You're just going to submit a patch file, so all I have to do is take all of your Project 1 submissions and then run your P2 patch on it, and then I'll have Project 2. So that's what those directions are. But it's worthwhile to look at this because of the rubric. Which is not, I just want to scroll that. That should say fork exec. I'll fix that. So you have fork and exec logic in your program. You have for final tests, and we'll look at, that's why I want to look at this, is to look at the tests, that you are successfully forking and execing a second child game process. That you're doing the named pipe for feeding the text map to the first child. That you are setting up pipes correctly so they can talk back and forth. And now we have the tests. Alright, so tests. Tests for P2. Player can't move into a wall. Maps don't change before and after attempted move. So this is what we saw before. That's that. So that's test 1. Test 2. Player can move into an empty space. Draw map has increased by 1. So if you recall in the write-ups, I was suggesting that draw map and post notice are little one-liners in your new map implementation, just to increment a couple variables that you're keeping track of. Right? You just create 2 private variables for the map class for number of draw maps and number of post notice, and each time each time gold chase calls one of those functions, you just increment that value by 1. And again, if you recall, I just should bring it up rather than saying if you recall.
Excuse me, sir.
Yes, sir.
Can you go back to the rubric?
In a minute. All right. Here's a good scheme.
Yeah. So.
Hang on. All right. So draw map has increased by 1, so you know that it should be draw map is 1, I suppose, unless I've got, yeah. So you call the constructor, your auto test program is going to get the number of rows, the number of columns. It's going to get these rows times columns bytes. What you do is you create a copy and you set it aside. That's kind of the original map. These two are just going to add 1 to variables. And then here's the deal. When you call get, your gold chase is going to call get key. You're going to feed it a keystroke to move the player, and then you're going to do some checking. So the way your map is going to look is like this. Now you have to do a little bit of testing because you're either going to end up with the player there or the player here. So you need to, you're the one that fed the map. You know that it's the 1st, 2nd, 3rd, 4th, 5th, 6th. It's either in the 6th or 7th bytes, right? So you check the 6th byte is player there. Check the 7th byte, whichever one it's in. And if they're in 1 byte, you're gonna, with get key, feed it an H. If they're in the other byte, you're gonna feed get key an L. Yes.
How should we approach testing arbitrarily large maps?
You don't, not for the auto test. You're not dealing with arbitrarily large maps. You're just testing your code, and so you're giving minimal unit tests, if you will.
And one more thing, map component draw map. It says add one to a draw map variable. In the rubric, it says that the draw map variable should increase by 1 times player 0. Is that a multiplication operator, the asterisk in the rubric? 1 asterisk.
No, this is this rubric tool, and Blackboard's sucking is what that is. Let me see if it looks differently. Once upon a time, that was nicely. Let me see if I look at it from a different view here. Yeah, you see how pretty that is? So when I look at it, it looks great, and really what counts is what I see. So yeah, I apologize for that. So each bullet is trying to be a distinct thing that you're confirming.
And good question about that. Is it like I know I have to look on my laptop, and whenever I write code in Linux and I open it in Windows, and none of the new lines are preserved. It just goes into one line.
Yeah, that's because DOS uses 13, which is carriage return, whereas Unix uses 10, which is new line.
Is that something similar? Could that be the reason why?
Oh, no, that's just HTML. That's all that is. All right. So you know that draw map is 0 when the thing starts up, so you want to confirm that draw map is a little bit larger then. Where is this? And you get those whenever you feed get key, right? Your auto test program is going to write a character, but your before your auto test writes a character, first it's going to read this variable, these are integers, and then it's going to read the maps. What does this say? Get key write in map. Yeah, this is just referring, you could just, I should reword that. That should just say write it to standard out, right? You're just rewiring standard out on the map side. So it writes all that to standard out. Your auto test is going to read all those from the pipe, and then your auto test is going to write out the character move. And so when you do that with the tests, you should see nothing move here, and you should see GPLR 0 move from either 6 to 7 or 7 to 6. Test 3, player can pick up gold. You want to confirm these changes. The gold disappears, the player moves. Draw map and post notice has both incremented. Those variables have incremented as a result of getting the gold. Change that to a 1. All right, then you're going to get 1G or G1. So again, you have to figure out which way to move. So you end up, when the map constructor is called, you get the byte representation of what you see here in memory. That's kind of your starting point. You figure out which way you need to move, in this case in L, to move to the right. it calls get key and it writes out the information, and in essence it repeats the information that we saw in the constructor, meaning the map's exactly the same. I pass it an L, and then I end up with this. But I have not received a new copy of the map from, well, let me ask the question. Have I received a new copy of the map? If I pass, I'm in auto test, I passed an L. When your game receives the L, it's going to move that character to the right and snap up the gold and do a post notice, and it's going to do a draw map. Is the auto test going to get a new dump of this map now that it's changed?
Yes.
Yes, it is. Why?
Because it's waiting for get key again.
Exactly. That's exactly right. Remember, your game's in a loop. So it moves and it immediately calls get key again. What is the first thing that your revised map class does when it calls get key? We get this variable, we get this variable. We can confirm they both increased from the first time through. And we get the map again, and we can confirm that it's changed the way we expect it to change. Yeah? And then what you do is remember, your auto test program has standard out to the screen still, so you just do cout statements to report on the results. Player character was here, successfully moved here, picked up gold, increased, right? You just do the affirmation statements. Or you can let the user interpret and say with the first get key, you can say post notice is 0 and draw map is 1, and then the second time through it can say post notice is 1 and draw map is 2 or something like that, and let the user just look at it and confirm that those changed.
So if draw map is called every time, no matter what, someone presses a key, that should probably be rewired.
No, I don't think so. I think that's fine.
You just check for 2 instead of
Yeah.
1.
Yeah. Test 4. Let me see, I wanted to jump down a little bit because it says something about 3, 4, and 5. So tests 3, 4, and 5 can all be done with one run. You don't have to kill everything and then restart everything on the gold chase side. So let me look at 3, 4, and 5 really quick. Pick up gold. Cannot leave map without gold. And can leave with gold. All right. So let me change this then. Since all 3 of those, what it needs to look like is this. Tests 3, 4, and 5. All right. So this is 2 rows and 3 columns. So that means we're either going to get that or the other way around. So one of the tests was to confirm the player cannot move. Actually, you know what I like better? I like let me think about this for a minute. Do I want to let me draw it the other way?
What about 3 by 3 with the bottom 3 open?
The more space I have, the more uncertainty there is, and a lot more checking I have to do to find the player. Well, I think I want to change it and do it this way. The reason is that, as I'm thinking this through out loud, historically people have more buggy code trying to move left or right off the map rather than up or down. So you're either going to end up with that or you're going to end up with that. And what you need to combine it, you have to confirm cannot move without gold. So if you're here you want to try and move this direction, and it should be unsuccessful, right? So that would be, in that case, that would be an L keystroke. And then you want to get the gold and confirm you got the gold. So that would be, put you there, so that would be an H. And then you want to see that you successfully moved off the map in the game, posted notice, and it exited, right? So it's either going to be LHH or HLL, depending on which side the player's on. And you just have to do a quick check. And then after each one of those keystrokes, you check to see, 1, it didn't change with the first, 2, that he moved and got the gold, and 3, that he left the board. This makes sense? So,
we have to send the space key for exit. And for like
that is an excellent question. Do you have to send the space key for exit?
Oh no, because we re-rolled.
So let's not look at exit. Let's just look at post notice. Yeah. It says you got the gold. Hit, what is it? Hit return or hit any key to continue. Where's that code? It's either in map or screen. That's an implementation that you got rid of. So there's no pausing any longer. All right. So what'll happen is once you leave the board, it'll do a post notice. It'll increment that variable, and then that program's just going to quit. And then you have a wait PID on the parent side to grab it, to kind of clean up and get that the child has quit. So with what we have so far here, there are 3 instances. The auto test you only run once. You only type a.out, or if you've named it auto test, you only type auto test once. It's going to fork and exec a child. Here it's going to try move the child, be unsuccessful, then it's going to pass it a cue to quit. Wait PID, grab the quitting child. Fork and exec again, feed it this map, figure out where it is, move it 1 space, give it a cue, it quits. So in tests 1 and 2, you're giving it 2 keystrokes. It's the unsuccessful move keystroke. I may as well do it. Doesn't matter. We'll move to L and then Q. Here, it's going to be L or H, then Q. And then here, it's LLH, Q, or HLLQ. Or there is no Q on these because it'll quit automatically when they leave the board. So let me change this. So if the example, so what am I doing? I'm actually dumping players. I'm not showing maps in these other ones. So I'll put 1 in G here. Keep in mind it could be flipped. Oh, that's right, because this thing just screws it up, doesn't it? I'm just going to leave it here for the moment. I will go ahead and create a nicely formatted rubric as a separate document that you can look at, so you don't have to parse this. But looking at it here with me, and I can grow this here. So if this is the example, then, and I'm not even showing the number of gold here. So maybe what I'll do is I'll go after class, before I post the daily diatribe, maybe I'll integrate the rubric into this document here. So let me stop looking at the rubric for this bit here. Then, so that'll be that. Test 3, 4, 5. What are we left with? We are left with test 6 and 7. Test 6 is just seeing that you get 2 players up there successfully. And how many people are allowing 1 player to move on top of the other? Okay, good number of you. So what I would like you to do is, if you're not allowing it, I would like you to make a modification to your original game to allow it. Hopefully that won't be a major change. It shouldn't be. And then we'll be consistent in doing this test. So 2 players on the map successfully, that's no big deal. And then this is just a test to see that one player can move on top of and back off of another character. And so that one tests 6 and 7. You're going to have 0. So you'd have something like 1 and 2 or 2 and 1. And then this would be, how about move player 2, H, L, Q, to have player 2 move that way and then back off and then to quit the game. And you just do a confirmation that you do have both bits on the same byte here, and when you separate them, you do have 1 bit here and 1 bit here, as you did originally. Or no, let me actually, it's all coming back to me now. You move player 2 that way, and then you move player 1 this way. So you're causing them to swap positions. Okay. And again, you have to do the checks. You have to reverse these if they're in opposite positions. And you do need to know which position they're in, because now you have 2 sets of pipes and you have to know which one to send the H to and which one to send the L to. Right? So it would be and then this would be oops. You have to tell both to quit. And that's it. That's all of it. So I currently have this due over the weekend. I'm willing to entertain another class meeting after the weekend, but I'd like a little good faith effort before the weekend then, so that Thursday isn't a dead class. So last time's when I did a code review, it was tremendously unsuccessful because I ended up spending a half period with each of 2 people. So I'd like to do the same thing again, but I'm not going to debug your code. I'm just going to nod and smile so that I can look at everyone's code. And again, this is just some accountability, so I can see you're making some effort to move forward with this, and then I feel more comfortable giving you a bit more time then. Okay? Deal? All right.